All right, so here, if I just check git status, everything is up to date. I've got my draft version going. I'm going to type in Jupyter Notebook. And we'll get everything started. Oh, okay, here we go. And so today we'll take a look at 0203, which covers dictionaries, flow control functions, and things like that. Okay. So here, so last class we spent a lot of time talking about lists and all the methods that you can do with lists, and then we also looked. I don't know what else we looked at. Just some other data types and stuff. Today we'll take a look at a dictionary. Okay, and so a dictionary is R doesn't have that. They're kind of like named vectors, but not really. Okay, so dictionaries are really they're used quite a bit in Python, and you have to get accustomed to seeing them. Okay, dictionaries are defined by curly braces. Okay, and everything comes with a key and value key value pair. Okay. So the key is whatever comes before the colon, and the value comes whatever after the colon. The keys can be strings, they can be numbers, they can be all sorts of stuff, okay? And then the values can be strings or numbers. So you can have strings match with strings, numbers match with strings, strings match with numbers, numbers match with numbers. You can kind of have that for your keys and your values, okay? So here I create my dictionary, which says Adam is 25, Bob is 19, Carl is 30. That's what we have. And then if I ask to print out or just say what is in the dictionary, there is our dictionary, okay? Dictionaries are unsorted. There is no inherent order to the dictionary. With a lot of these simple dictionaries, they end up being kind of sorted in the way I create them, but there is no inherent sorting to dictionaries. You cannot sort a dictionary, okay? That's just something, okay? You can also create a dictionary. I mean, there's several ways to create a dictionary, and one is you can use this function called zip, okay? Zip will take two lists, and they kind of zipper them together. So here I've got a list that says Adam, Bob, Carl. I've got a list that says 25, 19, and 30, and it will zip it will kind of match the elements of the two lists together. And when you call zip, it creates what's called a zip object, okay? Which in of itself, you have to use kind of zip specific functions, but you can create a dictionary out of a zip object, okay? And that's what I've done here. If I just call the zip object, it will say I've got a zip at this memory location. This is just kind of referencing the object. But here I can say, is the result of zipping this the same as this dictionary here? And it says yes, okay? Those two dictionaries are equal to each other, okay? So once you have a dictionary created, you can get the value associated with a key, okay? So here is the dictionary. I can say, what's the value associated with Bob? So I would say people, square bracket, and I give it the key, and it comes back and it says 19, okay? There's another function you can call get, okay? This is pretty much, they do like the same thing, okay? You can get the value associated with the key Bob, okay? So this also returns 19. The difference is that when if you did people Joe, Okay, Joe does not exist. That's not a key that exists in our dictionary. Okay, I only have Adam, Bob, and Carl, A, B, and C. I don't have a Joe. So when you call this and you say, what is the value with the key Joe, you get back an error. Okay. Whereas if you did people.get Joe, it's going to return a none. Okay. And so when it returns none, actually nothing gets output. You have to explicitly say print it out, and it will print none. Okay, so that's kind of the difference. I would say most of the time we probably use this, just a single square bracket. But if you need to be able to handle the possibility of somebody entering a key that doesn't exist without it kind of crashing, then you might consider using get instead, okay, for the dictionary. But that's what we have. Okay. So the key. So here I've got keys can be numeric. So I have 2 is associated with, and the values can also be lists. So I have 2 associated with the list 2, 4, and 5. I have the key is 1, and it's associated with the number 10. So I'll go ahead and do that. And if I say what's the value at which that has key 2, it gives me the lists 20, 4, and 5. If I say what's the value at key 1, it gives me a 10. Okay, so this is again, it pulls the key. This looks like, if you didn't know any better, you might think D was a list, and I'm asking for the object at index 1. Okay. But dictionaries have no indices. Dictionaries, there's no index, there's no order. Okay, they just have keys, and you can kind of reference these things there. Is that okay? What's happening with this dictionary? Okay, so dictionaries are inherently unordered. You can't use numeric indexes. Okay, if you provide a number, the number needs to be a key in the dictionary. So if I try to say what's at 0 index, it's going to return an error. It's going to say that key does not exist. Okay, you get key error, meaning that key doesn't exist. And so here, let's just take a look at our dictionary again. Okay, you can enter new entries just by saying here's people, and then you give it a new key. So I'm going to say Derek, and we're going to just assign the value 33 to that. Okay, that's going to create a new entry in my dictionary. Okay, and if you want, you can update the value there, and so you can say Adam is 26. So I can run this, right? And when we take a look at the resulting dictionary, we see that Derek, a new key, has been added to our dictionary, and then Adam, that number gets changed from 25 to 26. Okay, so that's how you can do this. If you want to remove a key, remove something, you can say delete, use del. Okay, and this will get rid of Carl out of the dictionary. And so if I look at the dictionary, now it has Adam, Bob, and Derek. Okay. Kind of like lists, you can pop. You can do a pop, which will kind of pull out that value and change the dictionary that results. Okay. But if you call pop, again, because there's no inherent order, for a list, pop will by default remove the last one in the list. But in a dictionary, there's no inherent order. Okay, it looks like Adam is first and Derek is last, but that's just an illusion. Okay, there's no ordering to the thing. So if you did pop, it's going to complain, and it's going to say we need some kind of key. All right, and so here I have to say, okay, let's pop Adam, and if I pop Adam, it's going to remove Adam out of this dictionary. The dictionary that will be left will be Bob 19, Derek 33, and when I pop Adam out of the dictionary, okay, it's going to, this function will return the value 26 because that's the value associated with Adam. So pop on Adam will return the value associated with the key Adam, okay? And then the dictionary that results will just will be the dictionary with Adam removed, okay? So it's kind of like delete Adam, except you're able to kind of pull out the value that got removed there, okay? Okay, so let's go back and have people A and people B, and let's say you want to kind of like combine these two dictionaries together, okay? If you wanted to like have, you know, we've got Adam, Bob, Carl, ABC, and then people B is Dave, Earl, and Fred, DEF, and if, let's say we wanted to combine these two together so we have a dictionary of 6 people. The command we use is called update. What update does is it takes one dictionary, people A, and then it updates it with whatever is found in the other dictionary that you provide, okay? So here's people A, we're gonna update it with people B, and then so the result is now people A has all 6, okay? It looks like we're kind of extending the dictionary, but there is no extend method for a dictionary, okay? And you can't take 2 dictionaries, you can't do a plus like with a list. With a list, you can do list A plus list B, and it kind of joins them together. You can't do that with a dictionary. With a dictionary, you have to do update. And the reason for this is because if there is a key that overlaps, okay? So if, again, take a look at dictionary for people A, and here's a dictionary for people C. Here I've got this key, Fred, that it already exists in people A, okay? Right now it says Fred is 27. If I update A with this dictionary, what it's going to do is it's going to say, oh, Fred already is in here, so I'm going to update the value with Fred to 99. And then as far as Gary goes, he's going to get added to the dictionary, okay? We're going to update the dictionary with a new key and value, okay? So that's done, and then when I ask what's in people A, we can see Fred is now 99 and Gary has been added, okay? And the dictionary now gets printed vertically because it doesn't fit in one line anymore, okay? So these are just kind of the methods that we can use with dictionaries. And you know, when you're first using Python, the beginning part is just learning a lot of the vocabulary, okay? Learning a lot of the kind of you know, the verbs, the functions, and the methods, okay? It's kind of like it's very similar, you know, very similar to learning a foreign language, okay? When you learn a foreign language, there's like 2 major parts to it, right? You have to learn the vocabulary, you got to learn the words and what they mean, and you know, how to say the words, and you also need to learn the grammar, okay? The structure of how to put the words together, okay? And similarly with learning Python, you have to learn kind of the Python syntax, which thankfully is not too different from R, okay? But you got to learn the vocabulary, and we have a lot of new words or new methods and functions and things. And that's just one part. You got to get kind of used to it and just put forth the effort in learning it, okay? We have these things called view objects for a dictionary, okay? A dictionary has something called a view object, and the amazing thing is, or I don't know if this is amazing, but they are dynamic, okay? So here I've got, I'm creating a dictionary called people with Adam, Bob, and Carl, okay? And if I ask what is people, it tells me it's a dictionary, Adam, Bob, Carl, okay? And here I'm going to create, so I've got the view objects are keys, values, and items, okay? And so here I'm going to say names are the keys. The keys are the names, and then the values in the dictionary are the ages. Okay, so I'm going to go ahead and do that. And so if I ask what are the names, it returns, it says I've got dictionary keys, Adam, Bob, Carl. And I ask what are the ages, it says dictionary values 25, 19, and 30. Okay, so here I'm going to add Ed to the dictionary. People is Ed, dictionary 40, okay? Notice I have not redefined names or anything, okay? But without having to redefine names, if I just say what is names, names now includes the new key that I've entered, okay? It's a dynamic view of the dictionary. So the dictionary has Adam, Bob, Carl, and Ed in there, and so names reflects that, okay? It's a view of the dictionary. And so does ages. Ages is also updated, okay? So these are, without having to kind of redefine them, they're linked to the dictionary, and as the dictionary changes, these things change dynamically as well, okay? There's only a few things that the view functions, the view objects support, okay? So because a dictionary is in of itself unordered, the view objects are also unordered, okay? We cannot say what's the fourth item in dictionary keys, or I can't say what's at index 0, because the dictionary is unordered. You cannot, so there's no index 0 for the dictionary, there's no index 0 for the keys that exist either, okay? So, but what you can do is you can ask what's the length, okay? So it's going to tell you that there's 4 things in length. We could say, is 35 in the list of values, or not the list, but in this view of values? And the answer is no, okay? So, so you can kind of check there. If you need to be able to do something with it that's a list, you can take ages, which is currently this dictionary view of values, okay? It's got these 4 values, and you could say, you can throw it into a list object, okay? So, so now we have a list. Age list has these things, 25, 19, 30, and 40, okay? So this is now a list. But the list that I've created is no longer dynamic, okay? This is just a static, plain old list. And so here, if I create another person, another entry into my dictionary, we're going to add Frank here, okay? The view object, the dictionary view object, is dynamic, okay? I said Frank is 29, and in my dictionary values, 29 now appears, okay? But the list that I created earlier, this is still just the list, okay? So the view object updates as the dictionary gets updated, okay? You pop the dictionary, you update the dictionary, you change any of these things in the dictionary, that's going to work, okay? The view object will reflect all of those changes. But again, it's unordered, and so you can really only do a few things. You can just say, is this value in the list of values, or is this value in the dictionary values? And it's going to say yes or no, or how long, what's the length of the dictionary values. You can do that, and that's really all you can do with those view objects, which is still very, very useful, right? You can say, keep updating the dictionary until this particular value shows up. Things like that. You can use those, but you can't do other list methods. And if you do, the list method is just a copy of the kind of the what's in the dictionary at that moment in time. Okay, as always, you can always consult the Python documentation, and you can always ask about Python dictionary. You can do like Python dictionary methods, and And there might be a few other things that I haven't covered, but I think I've covered most of the kind of the methods that exist with dictionaries. All right, so now we'll start talking about things as far as writing a program goes, okay, in Python. And these are, I think, topics that you're already familiar with, but again, the vocabulary just changes, and maybe the formatting also changes a little bit, right? So we've got if, else if, and else, okay? The else if is abbreviated elif, okay? So that's what we have. And so here we go. Again, the way Python establishes code blocks is with indents, right? You write if x is equal 0, then you write a colon, and then the next line, which is indented, is associated with that if statement, okay? As soon as you back out and bring the next thing to be back to the 0 indent position, the same level as this original if statement, then you could put in the else if statement, the elif, okay? And so here, I got if x is equal to 0, then we're going to print x is 0. If else if is greater than 0, we'll print x is positive, and else we'll print x must be negative, okay? So here I've got x is equal to -3, and then and it runs through it, and it prints out -3 must be negative, okay? No surprise there, all right? So I think when you're coming from R, the first thing you notice is kind of the sudden lack of parentheses and braces. But I think, I don't know, I think this is pretty easy to read, right? It's easy to read when it's nicely indented like this. Okay? And just like other languages, the else if or the else is only going to be executed if the original if statement is false. Okay? So here I've got x is 100, and I have if x is greater than 100, greater than 0, print x is positive. Okay? Which means this statement, else if x greater than 3, this will never get executed because there's no situation where this is false but this is true. Okay? And so this line will never get executed. The else will execute only when this statement is false. So x is 0 or negative or something like that. Okay. We have for loops. I think you guys are familiar with for loops. Okay. So you have some kind of thing that can be iterated over. Okay. So lists are iterable. Even strings and other things are iterable, okay? And it just kind of goes over every element in there. And so here you say for x in values, and we can print out x. And what we can do here is we can do y plus equals x, all right? And if you've used C++ or something, you're probably familiar with this notation. If you've never done that, then this is equivalent to writing something like this, where y is equal to y plus x. So it just kind of takes x and it adds y to it and updates y with that value. And here we'll get the running sum is that. Okay, so we start off with y is 0. We got 5, the running sum is 5, 7, the running sum is 12, 2, and the running sum is 14, and 1, and the running sum is 15. And so here I've got a string that says UCLA, UCLA. And so here we're going to just, for each letter, okay, for A in this string, which means it's going to iterate over each letter, it's going to print the uppercase version of the letter along with an exclamation point, okay? And so, so what this results in is it says UCLA, and then it even makes an exclamation point over the space just because you were really excited, and then it says UCLA again, okay? So you can write out your cheers that way. Okay, so that's what we have there. So those are your for loops. Wait, too many to. I gotta do. People to items. Oh. Okay, so you can also kind of unpack a dictionary. Okay, you can iterate over a dictionary. And so here I've got the dictionary people, and I've called items, which is another view object. Okay, and we're going to just kind of go through. And because as far as the dictionary items go, there's two things associated with it, right? You have a key and a value. And so it will unpacks the dictionary items. So if I just say, what is people and what is people to items? Okay. So the people to items is kind of this view object of dictionary objects, and it's going to go over this, and it's going to unpack this into your key and your value, and you can do statements with this thing, right? So you can do the key is Adam and the value is 25, so on and so forth. Okay, and then as far as with the print, I had to turn the value, which is currently an integer, I had to turn it into a string. All right. So you can do stuff like that. All right, we have range objects. So a sequence of numbers can be created with range. So in R you did something like 0:9, okay? But in Python the colons are important for other reasons. So we can't really use the colon in this way. So we have this function called range. Range 10 is pretty much like 0:9, okay? It creates a range of indexes that start at 10, or I mean that is 10 items long, but starts at 0. So it's going to go 0 through 9. So range 10 will go 0 through 9. Range 100 will go 0 through 99. Things like that. Okay. You have you can also, if you want to be a little bit more specific, you can also say range and use the start, end, and step size. Okay. By default, when you type in range 10, it's assuming you're providing at the end, and the start's going to be 0 and the step size is 1. Okay, so range 10 will create a range from 0 to 10. And then if you say for I in range 10 and print I, it's going to print out 0 through 9. Range 5, 10, this will start at 5 and end at 10, okay? But it doesn't include 10 when it ends, okay? So the range object goes up to, but doesn't include that last thing, and this default step size is 1. So here is range 510, and if we turn that, if we want the actual numbers, we have to kind of throw it into a list, okay? So I can do list range 5, 10, and that will go 5, 6, 7, 8, 9. Here, I'm going to turn this range into a list, 0 through 20 by 2. So what will this contain? So it'll go 0, 2, 4, 6, 8, and it will end where? Okay, it ends at 18, yeah? Whereas this, 0, 21 by 2, this will go up to 20, right? If you try to give it 0, 20.1, this gives you an error, okay? It says, I don't like seeing decimals, okay? So, so the range object only takes in integers. Okay. While loops, I think you guys are familiar, right? So here we have I is 0, print I until while I is less than 10, okay? So it prints I and gets up to 9, I becomes 10. So if we ask what is the value of I at this point, I is going to have the value of what? So if I say, what is I? Is I 9 or is I 10? I is 10, right? Because it ran this code and it printed out the 9, and then it runs the next line where I becomes 10, and then it's just when it reaches this statement now, is 10 less than 10? The answer is false, so it quits out of the loop. Okay. Okay, we have a break and continue, okay. So continue will just skip to the next iteration of the loop, okay. So here I've got for n in range 20, okay. So n in range 20 starts at 0 and goes up to 19, okay. And then we ask if n%2, which is the remainder, so if n is even, continue, okay? When it reaches continue, it skips any code that comes after it and goes to the next iteration of the loop, right? So when n is even, continue. Otherwise, okay, when n is not even, it's going to run the next following lines of code, okay? The things that's not associated, it doesn't skip the current iteration of the loop, okay? So what is this going to print out? One through 5, 7, 9 up through 19. Oh, I guess I held on to the shift button too long. Oh dear. What did I do? Stop this nonsense. Turn off. Okay. Okay. So we have that. Here, so I'm setting A is equal to 0 and B equal to 1. Okay, so this is a nice little kind of efficient thing assignment that goes on in Python. In R, you'd have to do 0 is assigned to A, 1 is assigned to B on separate lines, or at least with a semicolon. But here you can use a tuple and unpack them, right? And so you can say A comma B is equal to 0 comma 1, and A and B will get assigned appropriately. A max will be 100. We're going to start off with an empty list, okay? And then here I got while true, right? While true will run forever until it reaches a break statement, okay? So while true, we're going to take A and B, and this will, what will this do? This will take the current value of B and assign it to A, and B, the next value, A plus B, will get assigned to B, right? And so if the A gets greater than the A max, then we're going to quit, okay? Otherwise, we're going to append our current value of A to our list. So this is one way to kind of create a list of Fibonacci numbers. So we're using kind of the tuple assignment to get the the next value is kind of the previous two things added together, and we do that, and we get the Fibonacci sequence there. Okay, and then finally we've got functions. All right. So if we want to call a function, we have to use the parentheses. So if we say, what is print without parentheses, it's going to tell us, well, you're talking about the actual function print itself. Okay. Here, when you use the parentheses, it calls it and it runs it. Okay. And here it prints out whatever you give it, and there we have that, right? And you can always kind of get help on the function, or you can use question mark and it brings up this little, I don't know, whatever you call this thing, all right? You can even, if you want to read the whole documentation, you can pop it out into a new tab, okay? Help will print out the documentation right here and there, okay? A lot of times we want to define our own new function, okay? And so to do that, you use this keyword def, okay, for define. So we're going to say define shouting, and the argument is going to be a phrase, okay? And all we're going to do is we're going to say phrase is, take the phrase, make it uppercase, and add 3 exclamation points, okay? And then we're going to return that, okay? So here, I'm going to just say, all right, hi, my name is Miles, and then, but when I run it through shouting, it comes back, hi, my name is Miles, very excitedly, right? So it's just kind of funny how what the effect of changing things into uppercase does, but suddenly, like this sounds timid and this sounds a little bit crazed. But you know, if I try to if I give it an integer, right? If I say shouting 5, it says we've got a problem here, okay? Because here I just said take whatever argument you give it and call upper on it, okay? But with integers, there's no upper attribute, right? So so one way to kind of fix this issue is we could say, you know, let me redefine my shouting function, okay? And first, whatever gets put into phrase, try to convert it to a string, okay? So you say turn into a string whatever was put into phrase, okay? Then uppercase it and add the exclamation points, okay? So now if we say take 5 and shout it, then it works, okay? Like you just figured out, I don't know how many children you're gonna have. I don't know. Okay, and you can now give it whatever. This doesn't even make sense, right? We're passing it a dictionary, and it turns it into a string, and it turns it into uppercase, and it adds exclamation points. But if you know that doesn't make any sense, right? Unlike R, you can return multiple values, okay? So you can return them as a tuple, right? So we learned about tuples. They're kind of like lists, but they're not mutable. So here I'm going to define some kind of we're going to define powers of, and you give it a number, and we're going to just return the number, its square, and its cube. The square is number squared, the number, you know, to the third power. This is a silly number. So we've got powers of 3, and it returns 3, 9, 27, okay? Or you can unpack it. You can unpack the tuple into XYZ, right? And it will give you, it will say Z is 27, and Y is 9, or X, oops. This should be X, okay? X is 3, Y is 9, and Z is 27, right? So these values are all stored separately. Whereas if you just say the result of this is J, then J is a tuple itself, and you can reference the number by kind of using the index to do this. Okay, and you can, however, if you try to unpack the results. So I've got the result is a tuple of length 3. If I try to unpack it into like just 2 elements, it's going to complain that there's a mismatch. It's going to say too many values to unpack, right? We expect, here it's expecting 2 values to unpack because we're saying take whatever this returns and assign them to G and H, but it's saying this thing gives me back 3 values and I don't know which one I'm supposed to throw away. So it throws back an error. Okay. And then just like any other definition of a function, you can also provide it defaults. So here is stuff ABC, and so all it's going to do is just print out ABC. And if you don't give it enough arguments, it says you're missing one required argument C, so it's not going to run. You can provide it with defaults. Okay, this looks exactly like the way we assign defaults in R. Okay, and then now you can call the function without any values, right? And this works very similar to R. If you just provide it 1, it goes into the first argument, or you could specify the name, and it goes there. Here, you can give all 3. Okay. If you do this, A is 10 and B is 0, Python will get confused because it's going to think 5 was A and now you're doing A or something, so it's going to get confused there. Okay, it says got multiple values for argument A, right? But if you use all the letters, okay, then it's okay. I don't know, I did that really quickly. There's a lot of stuff. But this notebook is available for your reference. Okay, so I'm going to go ahead and I'm going to just restart and run everything. And so just, so everything is running. Oops. Okay. And again, just to kind of show how great Git is, okay, all I have to do is I close this thing. And as far as Git goes, I can check the status and it says we've updated this. So I just do git add, git commit, final 0203, okay? And then I do git push, okay? And so this pushes it, and now it's already on GitHub, okay? There's no need for me to like go into CCLE and add the updated files and stuff. And then all you have to do is do a git fetch to get my updates and git merge them into your directory or repository. Yes?
So the directory has to be the same as the name of your folder.
So I think I gave instructions earlier about forking my directory, and when you do that, you'll have on your GitHub account the forked repository. Then you'll clone your forked repository from your account to your computer.
Does it matter if the name, like if you rename it on your computer?
I don't know. I don't know what happens when you do that actually.
But actually, I was kind of confused because like I worked and downloaded it.
Yeah.
My directory.
Okay. Let me. Why don't we talk more? Okay.